Hello and welcome to another one of the SDM Foundation's Tech Talk videos for MMTV as well as YouTube. This video is going to be highlighting what we did during our 2023 summer lessons. And as you can see, we're starting off with mentioning some of the equipment that we use, such as laptops, 3D printers, there's some more of our setup with the laptops. We also used Arduino pieces, old desktop towers. These are Lego Prime kits as well as other Lego Robotics add-ons. Alright, and first we're going to talk about block coding just real quick. This is an example of it, and it's something that is used in a few of the programs that we teach over the summer. And one of those programs is Scratch or Scratch Junior. So here we are on Scratch's website. And if we open up a project, over on the left here, we see some blocks that we can drag over into our work area. And each one of these blocks is like a line of code or a function in code. And what block coding does is it gets you to start thinking in the right way to understand and write code. It helps you have the right sort of order of operations when you're thinking about trying to make something happen from scratch, essentially, which is probably exactly why this is called that. So as you can see here, dragging various blocks into the work area allows us to add a chain of functions. So now when we click the green flag, which is the event block that starts our set of interactions, it will follow each of the steps in order, and if there's nothing telling them to stop in between, it will do them simultaneously. So it will, go 40 steps or 40 pixels to the right. As you might be able to see, we have X and Y coordinates, and each one of those is one step in any direction. So if something is going to move a certain amount of steps, it's going to go, in a positive manner on the x-axis. And we can put the sprite, which is what we call the object for which we're attaching the code to, right in the center of our not workspace, but our display area, right, where we see what the code is actually doing for us. So you're working with a grid system, and the dead center is 0, 0. So there are other event triggers, such as when this sprite is clicked, like the one we just dragged on. So now, whenever we click on the flag, it will do what the flag says, right? As it's moving a bit and rotating. But when we click on the sprite, it moves it to a random position. So each of these events does what is attached to it. But now we have some control being brought in. So we brought in a control block that will make the process repeat however many times. So the default is set to 10. So when we drag that block over and put it before go to a random position, once we click on the sprite, it will go to 10 different random positions rapidly and then stop. So we're going to set the Scratch character back to the default center, and then click the flag, which has its new block asking the name, which pops up and then allows a text input. And something that we like to start off with in Scratch is having kids start with one of their tutorials, which gives you a little bit of a walkthrough on how to make various different things happen within Scratch. So as you can see here, what we're going to do is create our name in a fun and interactive little way. So we're going to get rid of these sprites. Bring in a different sprite. And so now this sprite has its own code that is completely separate from the other sprite. So the cat sprite 1 still functions exactly as it was. And since we have Ben, the second sprite, selected, we are not seeing any code because there is no code. And what you're able to do with your Scratch projects is share them to the world so other people can play them, check them out, see what type of coding was used to create the effects of your project. And it allows you to do the same. You can go out and see what other people have done and see how elaborate and in-depth the program can be. So next up is Spike Prime. So here are some pictures of some of our students taking their Lego robotics lessons, which involves first building a specific unit following a plan. And as you can see here, there's more block coding involved, and that is to allow functionality to these actual pieces. So by incorporating a little bit of battery powered gears and things of that nature, you're able to program these Lego builds to do various different things. As you can see here, a little clamping down of the face, as well as a manual input grabber. And this is Hopper, set to go on his own automatically. So Lego Prime, or Spike Prime rather, is definitely a fun and interactive way to get kids interested in coding and thinking about the real life applications of it. You can expand upon each build and try and create your own unique builds to try and accomplish the same sort of tasks that they give you to do with each thing that you're building. And obviously, the idea would be once you're comfortable enough, you can use it to do absolutely whatever you like. So the wires there that connect to the battery are from the gear pieces and other pieces that have a function. And you connect the battery to the computer via Bluetooth, and then in the program on the computer, that's where you do the block coding, which tells the pieces what they're going to do. It's very similar to how Scratch is. So instead of, move 40 steps, it would be, spin 3 times for that gear piece. And then as a result of the way the Legos are put together, it's going to create some sort of function. And so you can see the 6 wires neatly wrapped under the battery after being plugged in. And those 2 short clips right there highlight how both Scratch and Spike Prime from Lego use block coding. Looks very similar, functions the same way. With Scratch, you see the real-time application of what you're doing in the project you're making, whereas with Spike Prime, you have the physical result of what you are coding. Both very useful to get yourself thinking in terms of functionality and proper order of operations for making something happen, which is key to all types of coding. So they might not be learning a language directly, but they are learning the way to think about how all languages of coding are used. And that's really the more important part, because beyond that, everything is just syntax. So understanding the concepts of what you're actually trying to accomplish and, what you're doing, that is much more important. And we have the breakdancer here, a fun one to program. I think this one uses one of the camera inputs to change the type of functions it's going to do. As you might imagine, Lego Robotics was a very popular lesson, and it was definitely one of the easier ones to get footage of. So here are a few more examples of builds and functionality applied to those builds. And you can imagine how much more in depth you can get with this application Spike Prime, as well as the Lego kits themselves. Next, we're going to be talking about 3D printing. So there are sort of two aspects to the 3D printing. One is the actual printing itself, and that's looking at two printers right there. And then this is the other part, which is the design. And this is where you have to start, and this is where you spend a lot more time when it comes to the printing, or at least, active time, because sometimes the prints might take quite a while. But the software used to design them is Tinkercad, and it is a website that allows you to take pre-built shapes and bring them onto a 3D workspace, as we see here, and combine various shapes, distort them, and create whatever sort of design that you're going for. Obviously, the ones that we end up printing aren't massive in scale, but we have printed some very intricate prints, and it all comes down to how it is designed. And then after it's designed in CAD, we have to take it into another software called Creality in our case, and that's to slice the designed piece. So for instance, that cactus, if it was done right then, it would be exported as a certain file type and then imported into Creality and sliced to be changed into another file type that can be read by the printer. And during the slicing process, what it does is it determines what is going to be happening at each and every layer from the bottom up, because that's how the printer operates. It operates obviously from the ground up, because it lays the first layer down and keeps going up. And how the structural integrity and the structural design is happening on each layer is what you determine with slicing. Also allows you to, the software also allows you to determine if there's going to be, how much filament is going to be inside, whether it's going to be hollow or completely filled, or, it's going to have internal structural support in the form of squares for, 40, in terms of 40% of the total volume. So you have a ridiculous amount of customization with that, as well as the ability to put support brackets into the design as well, to allow things like arms outstretched to be printed properly when there's seemingly nothing under them. So the printer would just be dropping the filament into midair once it reached the arms. So instead, you can have some scaffolding to allow the actual arms to be put into place, and then the scaffolding comes off. So here we're working with Arduino, which is another robotics software and set of hardware that goes with the software, and you are able to code various different functions, just like with Spike Prime. However, the way that the coding works is a bit different. It's actually written out. There might be block coding, but I think more of it is written out code, like maybe Python, Java, things like that. I'm not sure the language that Arduino uses. It might have its own. And then as you can see, the putting together of the actual devices is more technical than Legos, and will teach about the connectivity needed between the various different pieces of hardware that allow the functionalities from the programming or the coding to happen. For our digital art lessons, we used a program or app called Procreate on our iPads that also have Apple Pencils, which allow you to draw on the surface of the iPad and actually apply realistic pressure and things of that nature to change what the actual drawing will look like. So we're going to go over some videos of kids making various different designs and artistic creations, and it shows you how easy it is to quickly change what type of design or what type of input you're having on the project. In this case, the proper way to call that or say that would be the brush. So what you've seen there was the changing of, a somewhat normal type of brush, which is, you make a stroke of the Apple Pencil and it puts something in the place where you just did a brush stroke. But after, we saw that just tapping would put dots on, and that was another type of brush. So it was a brush that was essentially just, Jackson Pollock splattering paint. And the brush size was then changed so that the splotches, the random splotches, would be bigger. And Procreate allows you to do quite a lot with a lot of pre-built brushes and functions, as well as the ability to customize them, create your own, and save them to use another time. And it also has the ability to easily animate things by using frame by frame creations. You can also duplicate one frame and then manipulate it just a little bit, and then continue to do that, making an animated project while maintaining the original characters a lot easier. So here we have inside a computer. So what we do here is just take some of our old desktop towers, break them down, go over all of the parts and what they do, how they fit together, as well as building them and putting them back together. So the Raspberry Pi is basically a mini little computer that you can have run various different software that allows for different functionality. So it's actually quite a robust little product there. And last but not least is video editing. And what we did with our video editing lessons is went over the generic way that most video editing programs work, with a timeline, a work area, the add-on features, bringing in media. But specifically, the software we used was Adobe's Rush, and it is free to use. There's also an upgraded version of it, but it is one that works like a lot of the other ones do, and we really tried to stress the fact that that was how most video editing programs worked, the key features to all of them. Hope you guys enjoyed the video, and we'll see you next time.